Hello. Today we are going to be talking about solving equations with surds, equations which involve surds. Ever wondered how you can solve a problem like this? Now I'm going to walk us through the steps of how you can solve an equation when it involves surds. Our steps are right here. To solve equations with surds, the method or the idea would be to collect terms with a variable on one side, right? Ideally, you'd want to make sure you've collected all the terms with the variable to one side. Factor out the variable if need be. Most of the times you would need to factor out the variable. So you're going to factorize and have the variable outside the brackets. Then the third step you want to do is to make the variable the subject. So in other words, you're solving to make x or to make y, or whatever the variable may be, you want to make it the subject. And finally, you want to simplify your answer, give your answer in the simplest form, and usually this involves rationalizing the denominator. In most cases, you're going to have to rationalize the denominator. And the example that I have right here involves all the steps that we have listed right here. So we're going to be using these particular steps, and let's solve this question together. So our question says, solve the equation. Our equation is right there in the box, but also giving your answer in this form, where P and Q are simplified fractions to be found. So when you are answering questions generally which involve surds, you always want to look out for the format of the answer. How should I present my final answer? Is there a specific format, that is required for the answer? So we're going to make sure that at the end, P and Q are fractions, and yes, they are simplified as well. Right, so step number one, we're going to collect our terms with the variable on one side. But before we can do that, we are going to have to expand our brackets. As you can see, we have our y term, which is our variable, on the left side of the equal sign, and as well as another y term on the right side of our equal sign. So we want to make sure we collect these, but here we have a bracket. So with brackets, we're going to carry out the basic laws of expansion. We multiply throughout by √3, just like that. So when we start, √3 multiplied by 4y, we have a 4y √3. Now take note that we normally want to write the whole numbers first, or the non-surd factors first, then the surd at the end. So when we multiply, we have the 4y multiplied by √3, which is just 4y √3. Moving on to the second term, √3 multiplied by -3 √3. That's going to give us a whole number 3. Then when the roots multiplied, √3 times √3, I just have again a whole number 3. This is from the basic law of self-repeated multiplication. If a surd multiplies itself twice, the roots would cancel out, and we just have the number or the argument. On the right-hand side of my equal sign, there is no expansion, nothing to simplify, nothing to collect, so it remains exactly the same. I'm just going to simplify this. 4y √3 minus 9 gives us a 5y plus a √3. So this is what we have so far. Now it's time to execute our first step, collect your like terms with the variable to one side. So I'm going to keep all the terms with y on my left side of the equation. So it means I'm going to have to move the 5y to this side. So it's become -5y. I also move the -9 to this side, so it becomes a +9. So effectively, I have a √3 plus a 9. Then our next step tells us to factor out the variable. Factorize and bring the variable outside the brackets. So if I factor out y, I am going to remain with 4 root 3 in the brackets minus a 5, like that. On the other side, we keep everything the same. Then we say step number 3, you want to make the variable the subject. In other words, solve for y. So when I solve for y, my solution would be y is equal to our root 3 plus 9, the whole expression divided by the bracket which is multiplying on the other side would come and divide. So the 4 root 3 minus 5 comes and divides on this side. See, since there is no operation here, we know this is multiplication. So if the bracket is multiplying on one side, we move the entire bracket as it is and divide it on the other side of the equal sign. I am done as far as solving for y is concerned, but the answer should be in a specific format. So our answer should be in this form, and our answer doesn't look anything close to that. So we are going to have to simplify. As we said, our last step is always to simplify your answer, and usually involves rationalizing the denominator. So we are going to rationalize the denominator. To rationalize the denominator, we are going to multiply the numerator and the denominator by the opposite of the denominator. Do watch out on one of my videos on rationalizing the denominator to key into this concept. So we're going to multiply the numerator by 4 root 3 plus 5. Here, I'll just write that one more time there. 4 root 3 plus 5. The same multiplier in the denominator, 4 root 3 plus 5. All right, I have a 5 on my mind for some reason. Okay, so this is what we have. So remember, when you are multiplying fractions, you're going to multiply the numerator by the numerator, the denominator by the denominator. Ideally, if you can put brackets, so you can use your law of expansion there. This is exactly what we mean by multiplying. We're going to begin our expansion in the numerator. So I have root 3 by 4 root 3. That's going to give me a 4 multiplied by 3. Observe there when our root 3 and root 3 multiply, they return a whole number 3. And the 4 is just a multiplier, so times 4. Okay, then root 3 times 5, we have a 5 root 3. We move on, our 9 times 4 root 3 would return a 36 root 3. So observe that the 9 would multiply with the whole number 4, then multiplied by root 3. Then finally, at the end, we have 9 times 5, which gives us a whole 45. Done with the numerator, we're going to simplify afterwards. Let's multiply and expand in the denominator. So your 4 root 3 times 4 root 3, you want to be very careful there. We are going to have a 16 multiplied by 3. Observe again, we have root 3 times root 3, which gives us a whole number 3. Then the 4 times 4 is the 16. Moving on, we have 4 root 3 times 5 would give us a positive 20 root 3. Then negative 5 and 4 root 3 would give us a negative 20 root 3. And finally, the last, negative 5 and a positive 5 returns a negative 25. From here, we are going to simplify. So in the numerator, I have a 12. And my two middle terms right here are like terms, so I can collect them together, put them together, because the third parts are the same. I have a root 3 and I have a root 3. So we would say these are like surds. So I can add them together, but observe when we add, we use the coefficients or the multipliers, the numbers multiplying with the roots. So I'm going to have a 5 plus a 36. And that's going to give me a 41 root 3. Then we still have our 45 right at the end there. In the denominator, I have a 48, 16 times 3. Then my 20 root 3 minus 20 root 3 would just give me a 0. Observe there, these two terms would cancel out essentially. Then I have the negative 25 at the end. Okay, collecting like terms one more time, we have 12 plus 45. These are ordinary numbers. They would add naturally to give us a whole number 57, plus my 41 root 3. Done with the numerator. In the denominator, I have 48 minus 25, which is a whole number 23. As it is, I have simplified my fraction to the simplest form. There are no terms that I can collect together anymore in the numerator or in the denominator. So we observe again, you take a quick glance at the format of the solution. They want us to give our answer in terms of root 3, but P and Q must be simplified fractions, which we must find. So they are fractions. So we are going to separate and write each term in the numerator over the denominator. 23 here is a common denominator to both our terms in the numerator. So we can separate like so, 57 over 23 plus your 41 divided by 23 times our root 3. I will write out our solution format. They say the answer must be in this form. Now we can compare where P and Q are fractions. So I can obviously match, right, that my P there is the 57 over 23, and our Q there is the 41 over 23, and of course our root 3 is root 3. This is the simplified solution to this question. So again, a quick glance at our steps. We simply want to perform our algebraic manipulation, which results in us collecting terms with the variable to one side, you factorize, you make the variable the subject, and then from there, simplify your answer, making sure that you give the answer in the required format, which might involve rationalizing the denominator. Watch out for more examples like these in upcoming videos.